Hello class, today we're going to be learning about what's called a 45-45-90 triangle. And before we get started with that, we're going to do a little bit of a review working with radicals. All right, so we're going to start by what is called rationalizing the denominator. All right, so it is not considered to be simplified if you have a square root in the denominator of a fraction. So what we're going to do is we're going to get rid of any fraction that has a square root down below. And what we learned the other day is when you take any square root or any radical, multiply it by itself, it poofs away the square root and you get what is inside. So when you square root of 2, you end up with 2. All right, so if we keep that in mind from what we did not too long ago here, we can multiply the bottom of this fraction by the square root of 2. But remember, we don't want to change the value of that fraction. So what we do to the bottom, we want to do to the top as well, because that would be just like multiplying by 1. So this would end up in simplifying down to 3 square root of 2 all over 2. And now you can see that my resulting fraction does not have a square root down below. So this is called rationalizing the denominator. Let's do the same thing over here in B. If you notice, B has a root 3 down below, so we don't want that root 3 down below. We're going to multiply it by itself to poof it away, but what you do down below, you're going to also do to the top, and that would yield 9 root 3 over 3. Now, before you move any further here, I want you to notice that you have these outside numbers that are not inside of the square root. Notice that number in the front, 9/3. You always want to double check that that is simplified. Now 3 is divisible, it goes into 9 is divisible by 3. So that would leave you with 3 root 3. Now this is simplified. So always take it one step further. Make sure you take a look at what you have. All right, let's do it again. The only difference over here is that you have a radical on top and bottom. Now it is okay to have a square root of 5 on top. So what we say is it's not simplified if it's on the bottom in the denominator. So we're going to do the same thing. We're going to multiply the top and the bottom by the square root of 2, and on top, now remember when you're multiplying a radical times a radical, you can bring those together into one little happy house. The 7 remains out, right? And you end up with 7 root 10 all divided by 2. And you can see in this fraction over here, this is already simplified. 7 is not divisible by 2. There's no common factors. So we say that this one is simplified. And now we may move forward. Now, there's a big difference between C and D, okay, that I'm going to bring to your attention. Now, we can multiply radicals together, okay, just like we did in the past or over here, but we can also divide radicals like you can see over here. Now, the process of dividing is just like multiplying. You can put them together in one little happy house, okay? So the difference between C and D is this 5 divided by 2, it could not be simplified. But what I want you to notice is 6 divided by 2 can be simplified. So in this situation, you'd be better off to simplify that fraction before rationalizing the denominator, because you might save yourself a lot of pain of further simplification if you can avoid it. Okay, so if you can see over here, I'm going to put those two together, and you can rewrite this as 4. And because you are dividing those, they can be simplified inside the radical, and you simply get 3. And look what happened. That square root of 2 went away, and you end up with 4 root 3. No rationalizing had to be done. Okay. All right, now let's just a real quick review on radical multiplication, just because we're going to have to do a little bit of this in a few minutes. All right, so in A, notice you only have square roots and then that 6 on the outside that are being multiplied. All right, so the 6 has nothing to multiply outside with, so you just leave it out in front. And then root 5 times root 2 is root 10. All done. Nothing from there. The only other thing you might want to double check is, can 10 be simplified? Are there any factors that are perfect squares that when you multiply them together will give you 10? that can be released and pulled out, and there aren't. Okay. All right. And this next one, you're going to multiply the 4 and the 4 because they're both outside. Root 2 times root 2 is just, boom, 2. And then 16 times 2 is your 32. Voila. All set there. All right. So that's multiplication. When you add radicals, you want to think about adding like terms. So if you had x's and y's, you'd group the x's together, group the y's together. Well, radicals really think the same way. This is like an x. Okay, so you have 3 x's and you have 4 x's. How many x's altogether? You will add the coefficients, so you end up with 7 roots of 2. And nothing else you can do there. Okay, the next one, what I want you to notice, again, remember we're grouping. We're going to put all the root 5s together. We're going to put all the root 2s together. And anything that doesn't have a root, we call that a constant. We leave it all by itself. All right, so let's go ahead and group all the 5s together. You have 2 for the first one, 6 for the second one. So that would be 8 root 5. And then how many 2s do you have? You have 10. And this little pretend that it's not that imaginary one in the front. It actually is 1 root 2. So you have a total of 11 root 2. And then that 5 all by itself. Don't lose. Okay, so it's just like saying 8x plus 11y plus 5. You would never put that 5 together with the x's and the y's. It's in its own little term by itself. Okay, so there you have a little review on simplifying radicals, rationalizing, adding, and multiplying.